What we're going to talk about today is the Red Hat Infrastructure Standard Adoption Model. I'm Mike Savage, Chief Architect with our Field CTO organization. And one of my side hustles is talking about infrastructure as code and how you can better run RHEL and manage RHEL at scale. This is something where I'm part of the Flightpath team. Flightpath is our top FSI customers last year, but we're expanding it to more and more customers as we kind of develop these concepts and flesh them out, make them more mature, etc. So with that, let's get going. All right, so I kind of want this to be interactive, and if you have any questions or comments along the way, just stop me, let's talk. So in your day-to-day operations, if you're rolling out a RHEL system and application code on top of it, what are some things that we're having to take into consideration? Anyone? I'm sorry? Yes, just then. So we're going to see a lot of overlap from that last presentation. We're just going to maybe extend it and go further. All right, so hardening, anything else? Patching, upgrades, yes.
Initial configuration.
Yes, yes. Disk space. User access, yes. Support, ongoing support, yes. What else? I'm sorry?
Compatibility.
Sure, yeah, oh yeah, definitely. Very good, very good. So where we're going in this is these considerations, the installation we talked about, scaling, we got to make sure how we scale up, down, etc. We talked about security, cleaning up after ourselves, the updates, patching, backups. If you're backing up, you got to restore. Okay, so we were hitting the high level, right? But if you really sit down and start noodling out on a napkin, there's a lot more in there. OS install, user accounts, creation, people leave, you got to remove them, right? System security policies. I think we were talking about firewall policy, etc. Got to take that into account. File system security, somebody brought up. Preventative maintenance, performance analysis, right? Ongoing, making sure everything's continuing to be performant. Unpacking, installing, RPMs, tarballs, compiling, on and on and on and on. So there's a lot there if you really boil it down, and it's probably not just one or two people, right? So there's a lot of people involved here. So why are we bringing that up? Well, what we're wanting to do is look at things from the lens of a standard operating environment. So what is that, and why do I need one? So myself and a couple of other architects, we sat down and said, let's just pull out the dictionary and put together a nice slide that defines an SOE. So we're saying that it's the model for the conditions under which we control our machines, systems, and processes. Now, ultimately, we just can't have SOEs running rampant all over the place. We need to boil those down to a discrete list, and then make sure that we're utilizing the right tooling to assimilate all these SOEs. And in doing so, that's going to lead to that standardization. It's going to lead into automation, and that's where we're going to really achieve and understand value. So what are these benefits that we're going to realize when we do this? Efficiency. Yes.
When you talk about these SOEs, and if you can really just please talk about how we might apply that to containers so that we can build SOEs that are based on a kernel so that we can then run. Yes, I'm thinking about our environment, and we run RHEL 4 all the way to RHEL 9, and so it would be really awesome to understand how we do this so that our, not that RHEL 4 is great, but can separate that kernel from the app stack.
Yes.
Thank you.
All right, we just called an audible. So when I get to that section, we're going to flip to a different playbook. All right, so we can look at that in more detail. And I'll kind of touch on a lot of this as we go along, and that concept is core to this SOE and the infrastructure standard adoption model mindset. So we'll see that kind of unfold, and then when we get to that section, I'll pull up another deck, and we'll flip to some other slides that kind of highlight that, because underneath it all, the ISAM is a sneak attack to running operating systems and applications on RHEL as close as you can get to containerization without actually doing it. You're going to be doing is all the things that you actually achieve when you're building containerized apps, but you're just doing it with automation, et cetera, et cetera. So we'll get to that. So efficiency, simplified onboarding. Somebody said support earlier. Enhanced compliance and security. That one's big for me. I like security shift left. I don't like security being an afterthought when the app's ready to ship and everybody's like, oh yeah, now let's check things out. Now let's scan it. No, we need to be talking with the security team sitting beside me at my Scrum meetings. And then healthy pattern, sustained automation. So all of these things are going to be able to be realized, and in the end, we're going to have lower cost and effort, and let's focus more on doing cool stuff and less of the mundane toil of seeing what systems have the right firewall policy, right? Let's automate all that, get it all on the same page, same sheet music, and then we can all innovate together. So if we go back roughly a decade, the Linux management, or the Red Hat Enterprise Linux management scene essentially consisted of satellite, and who knows the other one? Any guesses? Identity management. IDM. Okay, so you have satellite, and little known fact, identity management comes with a RHEL subscription. It's not, you don't have to pay more, you just get it with RHEL, right? Nice little bonus. So using satellite for our content lifecycle, doing what it does best, RPM's great, but if your repos are always pointing at the latest packages, you're going to get the latest packages. That doesn't really do good for software lifecycle. So satellite's going to allow us to do what it does best, a secure software supply chain. And then identity management is going to do things like allowing us to set up HVAC, a consistent SC Linux policy based on application teams. So it's just not one size fits all. You can even actually have it to where different SC Linux policies are stacked. Native AD integration, okay? This is one thing. A lot of partners we work with, cloud providers, a lot of those cloud providers have their own identity systems, right? Their own identity authentication. With IDM, you can use it as a shim in between the cloud identity, and even as a pass through for your AD, so you don't have to get tied into that particular cloud. It makes everything nimble. And again, like I touched on, it's included with RHEL. So this was around Summit 2015. These are the two players in the game. So Red Hat published, and there were several talks that year at Summit, the 10 steps to build an SOE. And it's essentially a guidebook on how to manage satellite utilizing best practices. And in the process, you're going to know how to care and feed for an SOE. It's 300 plus pages, okay? And all of these pages themselves, even some of these sections, link to other areas. So it's actually more like 1,000 plus. That's a lot, isn't it? And I don't know, is this the deck? We might see it in my Audible deck. Yeah, here it is. So not only that, it's point and click. It's like go to this page and select this drop down and hit this radio button and hit this tab and then go over here and do that, and do this. And then, oh, by the way, you might have to run some command line stuff too. And that's just for like one section. Or maybe one part of one section. And there's 10 sections. So remember, we had all those considerations earlier on the things that we have to take into account to roll out RHEL and applications and workloads. Now, to do it the best way using satellite, we're going to have to take all this other stuff. Like there's the first 5. Our management infrastructure, mapping our topology. Now, don't get me wrong. The SOE document is great for understanding the best way to set up satellite to do these things, okay? So you can use it as like a guidebook for understanding. Satellite gives you enough rope to hang yourself 10 different ways. So this document is going to help you understand the right way to do satellite. But ultimately, you get to the end, and what does they say? Automate it. And even then, it's not even really automation. It's saying you should automate it. That's not a lot of help. So, again, I'm not belittling this document. Lots of great information, but let's see if we can take this a step further, all right? So we're talking about all those things that we're considering. Servers, virtual machines, the cloud, networking, firewall rules, security and compliance, apps and the workloads themselves on top. All these things we're trying to consider, right? All these different teams. But if you're automating within these teams as silos, you're still siloed. And typically this all comes as a result of one team having a particular goal they need to achieve and kind of going it alone, right? We got to automate our cloud. So we're going to use the best tool that we know about for this cloud over here. And, you know, or I know Terraform. All right, we're going to use Terraform. No, over here on Azure, we know Puppet. We're going to use Puppet over here. So, and that's just cloud, right? So if you're automating in silos, you're still siloed. So what we want to look at doing is adopting Red Hat infrastructure the right way, in our opinion. So we're going to move away from that fragmented approach, and let's embrace that standard operating environment. What does that mean? We're going to get away from the snowflakes. Automated snowflakes are still snowflakes. We're going to move away from that, move away from all of these disparate tool sets, the manual, right? Looking through that SOE document, pointing and clicking all over the place. How did you roll out that SOE yesterday? I don't know. I follow this document. Here's the guide. Let me try it. I think you know the story, right? Also, I think somebody mentioned support earlier. Documentation gaps, tribal knowledge, right? How do we automate the way that this storage array is integrated with our virtualization platform? I don't know. Brian did it. Where's he? Oh, he left last week. He works somewhere else now. So the silos of expertise, let's get away from that as well. Legacy deployments, technical debt, static images, please no. No static images, please. We want to iterate. We want to layer. We want to layer our systems, not the static images. All right, so we had the 2 players earlier that we talked about, satellite and IDM. Now, let's bring in Ansible to the party. We're going to automate all the things. And then on top of that, we also have the hybrid cloud console today, so we can utilize insights where it's strategic. And then in this particular case, we're really going to focus on Image Builder. How many people here use Packer? Yeah? I love Packer. It's great. But Image Builder has really come a long way. And now we can use Image Builder to do a lot of the same things that Packer does. And because of Ansible and all the integrations that we have across the page here, we can do it all. So let's look at it from a holistic point of view. So utilizing satellite, IDM, Ansible Automation Platform, Image Builder. IDM is going to allow us to tap into that Active Directory trust, We could even do some API integrations with ServiceNow if we wanted to do integrated ticketing. Those hybrid cloud services, image builder, building images that are portable across all of these footprints, or even these platform processing types, because anywhere RHEL runs, you can do all these things, run all these workloads. And so this doesn't say you need to do it all, but it's just saying you can run in multiple data centers. You could run in a data center in one cloud, or you could be all in on one cloud and do it in multiple regions across the globe, or you could even be multi-cloud. We're going to integrate all these things together and achieve it via the Red Hat infrastructure standard and adoption model. How, Mike? How do we do that? We're going to do all these things. Curate our content, central source code management. Via IDM, we can use the enrollment and authentication. We have a new user coming on next week. We put them in IDM. That user is available across all of the RHEL systems that we say they should have access to. You don't have to go to each system and do it. When they leave 6 months later because they're an intern, just turn it off and it does it all. SSH keys, Kerberos integration across all systems. It's a beautiful thing. Now, provisioning and automation. We can also do pre and post provisioning configuration. Ongoing, day 2, maintenance and automation. My security buddy sitting next to me at the scrum table. Let's sit down and figure out how we want to do our compliance definitions, right? I'm going to run OpenSCAP scans on an ongoing basis. And then also vulnerability analysis. We're going to test our systems as soon as we build them before we deploy. And if it's broken, pull the logs, destroy that system, and iterate. All across these various platforms using that standardized image delivery, image builder. Let's see. Oh, and remind me, Bare Metal. Bare Metal's invited to the party too. And we'll talk a little bit about MBD and Clevis and Tang. Got a little success story from a couple weeks back. Pretty cool stuff. All right, so how do we do all this? We have certified collections from the Automation Hub that are composed and written to do that. Red Hat RHEL IDM is for configuring IDM primary replicas and clients. I have more slides that go into more detail in each area if you're interested, but this is just kind of telling you the collections that are going to do some of this heavy lifting for us. For satellite, we have satellite operations, RHEL system roles. This is where we're going to deploy satellite, create and configure everything. That Red Hat SOE document, it's 300 pages long. Talked to some satellite administrators before, and I'm like, how long did it take you to set up your satellite? And they're like, forever. And then we'll look at some code here in a little bit, but I have a demo where I do the same thing in like 15 minutes, and there's like heads are exploding, right? So, and I can do it again and again and again. So that's for satellite. And then finally we have Ansible, bunch of add-on. There's so many I can't list them all, but that's why I put star. But mainly we also have controller, and then some older versions we still have to use Tower, but those are all going away mostly. That's going to allow us to configure Ansible automation platform, create and import assets, etc. What's really cool there is that we can do infra and config as code for Ansible automation platform and actually have AAP configure itself. Right? We're going to automate the automation. So meta. Now, it's called ISAM. It's kind of two things. It's the infrastructure standard. That's what we just talked about. Satellite, IDM, AAP, image builder. That's the infrastructure standard where we're saying that's our opinionated model, our opinionated deployment of all of these RHEL management tools together. Now, you also need to have a process and how you do things from day 2. You know, it's about the workloads ultimately, right? So we need an adoption model to do that. That's where the adoption model part is. So it's the infrastructure standard and the adoption model. So let's look at that. Your typical GitOps Moebius loop. We want to sit down, figure out what we're trying to deploy, all come to agreement, and then we're going to think about that, review, we'll define, deliver, then deploy systems. Once we deploy, we could configure, etc. Then depending on where we are, we would either manage and maintain or test destroy. So if it's an existing system where we're patching, that would be the manage maintain. Or if it's some new code that we're trying to test, we're going to roll out a test system, configure, run our testing. If it's good, cool, we can move on. If not, we'll learn from that. But ultimately, we destroy that system, and around the loop we go. So let's envision that Mobius loop more as like a pipeline, a software deployment lifecycle pipeline. So at the start, we're going to look at that new code, maybe some new revisions. We just had some type of vulnerability that was just realized. So Red Hat came out with a patch. That'll be our errata. Maybe some other vulnerability data that we have our own from our own internal testing. We can use that. And then other configuration recommendations. Maybe that's the app team sitting down and say, hey, we just had some new SE Linux things we've been working on. Let's add that to our configuration recommendations. So then we're going to monitor, review, define. Now in satellite parlance, the define part is the publish. That's where we would publish like a content view. That would consist of our binary content, the RPMs, etc., configuration code, templates, application code, and it could be containers, maybe. Then we deliver. That's typically promote. Deploy is provisioning within satellite, configure, and then that manage, maintain, test, destroy, and then around and around we go again. So then let's ultimately look at it as a series of pipelines where development is then feeding that new content into the next stage. So our QA stage, its new content is coming from development. But because we already have an existing deploy system or deploy life cycle, we don't have to do all the definition, etc. It's more compact, very similar. To get your true definition of GitOps, you have to have feedback into the previous loop. So that's where any of our feedback from testers, maybe we look at our results or error reports of something went in the ditch. We're going to feed that back to the previous life cycle, and then on and down, however many stages your particular organization likes to use, all the way to production. So if you've seen workflows within Ansible Automation Platform, we can do the same thing with a workflow template where each of those stages can potentially be a job template. So here's our definition job template where we update the errata, filter the end date. Now that's something where we're using infrastructure and config as code to do that within satellite. So that 20 pages of the SOE document on how to do that, it's all defined there, and the intelligence and the knowledge of how to do that is in the Ansible collection for satellite. So now we're just saying, I want to update the errata filter end date to last week. Run the automation. Then we'll promote our new content views and composite content views to dev. That's where we do the deliver. Next, we'll build some test systems from host groups. That's the deploy. And then you can use your imagination, whatever you would like to do as part of your lifecycle deploy. In this case, we're saying maybe take some snapshots for future tests. Next, what's the whole point of